Hello everyone, my name is Eric Bock and I'm with Navigation Electronics. Today we're going to discuss how to set up Esri's Collector for ArcGIS on Android along with a Trimble R2 external GNSS receiver and then show you how to display the mean sea level elevations. So to get started on my TDC 600 here, I'm going to click on the Play Store and I'm going to type in Trimble Mobile Manager. Now you're going to want to make sure that you download the latest version, which is 2.3. I already have it installed, so we'll just skip this step. Next thing we're going to do is search for Esri's Collector, and you'll notice there's two in here. On Monday, Esri released Collector for ArcGIS Android version 20.1.0, build 2913. Go ahead and install that one, the Collector for ArcGIS. And keep in mind the symbology of this icon because it's not going to display the word Collector for ArcGIS when you look at it on the device. I'm only going to run the latest one. Okay, now before we get started, I want to talk briefly about setting up the Trimble R2 Bluetooth. Now, if I go into my connected devices in Bluetooth, you'll see I have an R2 in here. Now, some people like to go in here and actually click on it to connect it, and that's not something we want to do. The reason being is the R2 has built-in Wi-Fi, and if you try to connect like that, it tries to connect to it like a hotspot, and it's going to then check this internet access box. And if you go out and you try to use an internet connection like a VRS, it will not work. You'll get some errors. So if you have any issues connecting to an internet connection with an R2, make sure you go into Bluetooth devices, go into the settings, and make sure internet access is not checked. All right, now let's get into the software. So we're going to run Trimble Mobile Manager to start off with. Once this comes up on the screen, at the top left corner you'll see the menu icon, or some people call it the hamburger icon. We're going to go down. I'm going to start with application settings. We're going to work our way to the top. First thing here at the bottom, the default comes in meters as far as your units. But what I do want to talk about here is this battery optimization. If you read this here, it says it can interrupt or prevent position delivery. Please ensure your Trimble apps are not optimized. By default, when they install on this Google device, they are optimized for the battery. So you just click on Open Settings. And then I like to click on the word Not Optimized and choose All Apps. Scroll way down, there's a ton of them in here, at least on my device, till you see Trimble Mobile Manager. Highlight it and say Don't Optimize, and then click on Done. Now once we go back to the Trimble application, once you do that, that message then just kind of disappears and you won't see it there. Now for the share location, in the past we used Trimble's third-party software like this, the Trimble Mobile Manager, or the in-between software before Collector. We would use that to set up mock locations and then share the location and along with some GNSS metadata. The way it's built in with this new Collector for ArcGIS, we can skip this step. So I'm going to go back to the menu, and next thing I'm going to do is click on GNSS Configuration. The default is set to auto when you first start this up, but I want to punch in my own base station. And what I'm going to do here is bring up a list of, oops, sorry, wrong list. Let's bring up the list here. This is a list of real-time networks amongst RTX that we have in the NEI territory. So you see here on the left I have the states and then who the agency that runs it and then how do you connect to it. If it's an in-trip connection, you need to type in a username password. All of these VRS or single base station direct IP stations are going to have an internet address and a port. Now I just put some generic ones here that I usually use, but for Alabama, for example, they have single base throughout the state. So you may have to go look up and find out what base station is closest to you, and you'll punch that in as the port. Arkansas and Florida. Florida, you can go either way. You could go with direct IP or you could go with a network solution. We have that set here with the port 10,000. So I have this list. If anybody needs this, feel free to reach out. We'll put it up on our web. All right, let's get back to it here. So I'm going to click on Custom Local, and then here are my settings for Louisiana. I have my URL, my port, and then you'll get this mount point. And there's a bunch of them in Louisiana for different things. I just choose one that covers the constellations I need and the format. The next setting in our list is the GNSS source reference frame. This is one of the most important settings for our custom local correction sources. If you look in here, we have the first option is auto. I've actually set this up and the data comes out well. But what this is doing is it's using your current location to find the most current local datum. You can also come in here and select what the specific datum is, and you would need to get this information from the real-time provider. In my case here, the Louisiana system's running on NAT 83 2011, and the epoch is 2010. Now, there are some cases, that'll work for most states, but in areas that are tectonically active like California, you may have to come in here and change this to a different epoch. All right, so we are going to go down to our next setup. You'll see my username and password set in there. And then the last one here, well, second to last one here is the GNSS output. I'm going to leave mine as same as source, and what this is going to do is it's not going to do any transformation. So my data is going to come in as NAT 83 2011, epoch 2010, and then it's going to push those coordinates out in the same manner. Now you could come in here and say auto. Auto would be just like it was in the last time. It would find the most your current location and then find the local coordinate datum. The next thing is select from list, where you could go through this list and choose a different reference frame to pick. In this case, you could choose the NAT 83 2011 again. Since my data is already in 2011, I'm going to leave it same as source. Now, if you want to find out some more information about this, I'd recommend going out to Trimble Community. And Matt Morris with the Trimble Mapping and GIS team wrote up 5 articles on Friday, or posted them on Friday. And in here, I'm just looking at part 3 of this series, and he goes into a lot of detail here about what exactly all these things are doing. He actually outlines the whole process that we have in this video. So if you haven't done so, check this this link out to Matt's blog. I'll actually post this on our video as well at the bottom in the notes. Now here's the new thing that you need to make sure you do if you want to set up mean sea level. You need to go to this Geoid tab, and the first time you use this, you'll need to scroll down and you'll need to select the geoid that you would like to use. In my case, I chose Geoid 18, and once I did that, it started to download the file and put it inside the necessary folder. Just need to do that once. Okay, so there we go. There's my real-time setup. Now I'm going to hit my menu, and I'm going to go to Position Source. Now the first time you do this, you'll need to come in here and make sure you choose the Trimble R series, and then you'll have to click on Scan Bluetooth and grab your R2. Mine is already set up to do that. Once that's done, we go to Home. This only has to be done once. I'm going to go and slide on Connect to my R2. Now I have my R2 outside today, and it's a little far away from me, so we'll see if this thing's going to connect up here. Hopefully it'll find it. And when it does, you'll start to see the satellites pop in, and the real time is going to pop in here in a second. So we'll give it a second to find itself. All right, so my RTK finally kicked in here. It says I'm at 0.02 feet. You'll see my orthometric height at the bottom. That's that MSL. Now, with this software, we don't have the ability to punch in an antenna height. My elevation is, my device is set up on a control point in my yard. It's at about a foot here in New Orleans. So if we added 2 meters to that, that's getting me in the right spot. Once I've confirmed this is working, I just shut this down by pressing that connect button. You don't need to do this anymore. It's set up, it's configured, it's ready to go. All right, now let's run Collector for GIS. So it's going to sign in, and it's going to come up with the map screen. I'm going to have to back off here and show it to get to my profile. So I'm just going to hit the back button right here. And I want to go to the top left. That's the profile, that little icon of a human. And we're going to scroll down here to location. We're going to click on provider. So right now it's the integrated provider. So right now it's using my TDC 600. I need to actually click on provider. And then what I'm going to do is hit add provider. And the R2 shows up in my list. I hit the next button. You give it an antenna height. I'm set up on a 2-meter fixed height pole. So I'm going to set 2 meters. Now I need to make sure I set this R2 to my current device. So I just click on it and it'll pop it up into the current location provider. Second step is your profile. So we're going to add a profile. And what I'm going to do here is it's saying, what is our GNSS coordinate system? Well, that was that same as source that I set up, which is NAT83-2011. So I'm going to hit the search button up here, and I'm going to type in 2011. And I'm going to hit search. Now it's going to come up with a few. I just like to grab the one that's GCS NAD 1983-2011. I'm just going to grab this 6318. All right, I verify it's checked. I hit next. Now it's asking me what my map coordinate system is. Well, this is Web Mercator. That's how mine's set up. I published it to ArcGIS Online. So you need to watch out here too. You have 4 different Web Mercators. You have Web Mercator and Web Mercator Auxiliary Sphere. If you select just Web Mercator, when you go to run the GPS, it's not going to run right. It's going to act all funny. It won't connect. So make sure you choose the Auxiliary Sphere. We're going to hit next, and then it's going to want us to zoom into where you're working. So I'll be working in the south U.S., or in this case today I'm going to be working here. I'm going to hit next, and then I pick my transformation. The top one is usually the recommended one, and that's the one I'm going to be using. I'm going to hit next, give it a name. I'll just say VRS Demo, and hit add. Now, just like we did with the provider, we need to make sure that we set that to current. So now my VRS Demo is set to current. All right. If you need to change any other settings in here, like your accuracy or your streaming, your photo size, things like that, your units, you can definitely set that up. I'm not going to mess with that today. So the next thing we're going to do now is go into our map view. All right. So there we go. My accuracy, you see GPS accuracy, 0.3 inches. If I click on it, you'll now see the word altitude populated here, and there's that 1 foot I was talking about. And if you want to verify, I have a data sheet here. My orthometric height. Now this was done a few years ago. I need to probably use the R2 and run the DL app and log a new static position. But there's my elevation. There's my orthometric height, or my mean sea level height, 1.18. And here in Collector, let me get that back up. My altitude's bouncing around 0.9 and 1 foot. Maybe I sunk an inch over the last 5 years. I don't know. Maybe so here in New Orleans. All right. So some things I want to point out right here. This altitude is coming across from the Trimble Mobile Manager software. Now, when I go to log a point, the default, let's just say test, the default is going to log height above ellipsoid still. So Esri is still logging height above ellipsoid, even though we saw mean sea level in the altitude field. You're going to notice too that I have 2 other little attributes that I program these in using an arcade expression. I'm going to show you how to do that in a minute. So these top 2, MSL meter and MSL feet, are the arcade expressions that I built. So you're able to see mean sea level in the field real time using the GPS accuracy details. You can see mean sea level under altitude. And then when you log the position, if you program up some arcade expressions, you'll be able to see your mean sea level there as well. And then finally, I'm going to show you a way. I have a mean sea level attribute I have in here. I wrote a little model in ArcGIS Pro that we're going to run on this ArcGIS Online feature service, and it's going to populate that mean sea level. And then you could see it back in the field as well. So that's the basic setup. Let's now fire up ArcGIS Online so I can show you those settings. So here is my web map. So if I open up my web map here, we're going to go in here to the Collector MSL Field Feature Service. I'm going to click on More Options, and I'm going to say Configure Pop-up. Now, if you scroll down to the bottom, you can click on Attribute Expressions, and you can click on Add. We're just going to go look at the 3 I built. Whoops, sorry. Let me just edit it. So this is the mean sea level meters one. So this is just the default. So basically you just type in this round, open parentheses, geometry, parentheses, dollar feature, and then .z. Now, if you didn't have round in here, you would just get this long, since it's a double field, MSL would be a really long number after the decimal places. So Matt Morris with Trimble kind of showed me this trick to throw the round in there, and it just puts it to 2 decimal places. But that still gave me mean sea level in meters, and I wanted to change that. So I took that one, and I just added in a meters to feet conversion here, and that's how we're able to display mean sea level in feet on the device. So by running those expressions, then once you save the expression here, it pops up in this field here, and you can say Configure Attributes, and I just moved them to the top. They show up at the bottom down here, and you just highlight it, and you hit the little button up here, and you can bring these expressions to the top. All right, so that is how we did the expression. Now let's go look at my ArcGIS Pro. So here's that same feature service, Collector MSL Field, and you can see here that we could probably do a refresh, and our new feature class is going to pop in. Looks like my coworker added some in here as well down in Florida. That's Aaron McCormick's data. Well, if I scroll over here, I've run the model already on some of these, but if I scroll over, you'll see some of my mean sea levels here are nulled out. I basically wrote a model. Let's make this a little bigger here. That says, okay, I want to find all attributes under mean sea level. So we're going to look for the Collector MSL field where mean sea level is null. So it's going to grab those that are null and select them. And then I tell it, calculate geometry. Now, even though Esri stored the altitude is height above ellipsoid in the attribute field, the geometry of the feature class is actually in mean sea level based on that geoid 18 we had in Trimble Mobile Manager. So if you do a simple calculate geometry, I set mine to mean sea level, and I want to grab the point Z coordinate, it's going to populate with MSL. Now keep in mind that's in meters. So then I do another calculation that changes meters to feet. And then at the end I tell it to clear the selection. So if we run this model, now since I'm going to be sharing this model out, instead of making it to where you just run the model and don't have to set anything up, I set it up to where the customers can pick their input reference frame and things like that. So now if we go to view here and we go to catalog pane, if I go to my model, we'll just run this. Mean sea level is null. I'm not changing any fields, but you could. I'm just going to hit run, and it should go in here and populate our fields. So now if we come over to mean sea level, my model's done running. I may have to hit refresh here on the attribute table, and there we go. So here's mine in New Orleans, 1.09. I think my my file here was 1.184. So I'm about an inch off. It's not too bad. I do need to rerun my control point with the new geoid model. Anyway, I just figured I'd show this. Pretty cool how this is all working now with Esri. Now this is on Android R2 centimeter from Trimble, along with the TDC 600. If you all have any questions, feel free to reach out to one of NEI salesmen or saleswomen. Our YouTube channel will have some more videos coming. I'm going to do another quick video on how to set up the TDC 150 with these same settings for Collector. All right. Well, I appreciate your time. Stay safe. And until next time, y'all have a good one.